In this episode, we're going to make the shell environment feel like a friendly room you understand rather than a mysterious place that sometimes behaves differently for no obvious reason. Beginners often notice that one terminal session seems to have the right tools available while another does not, or that a prompt looks different on one machine, or that a script works for one user but fails for another. Those experiences are not random, and the reason is that the shell is shaped by an environment, a set of variables and startup behaviors that tell it where to look, who you are, and how to present itself. We will focus on four essentials that show up constantly in Linux Plus Thinking PATH, HOME, PS1, and startup files. The goal is to understand what each one represents, why it matters, and how different startup files can cause subtle differences between sessions. Once you have that mental model, you can read scenario-style questions and quickly spot the real cause without chasing distractions. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A shell environment is easiest to understand if you treat it like a bundle of context that gets handed to programs when they start. That context includes variables like your username, your home directory, and where the system should search for executables. When you open a shell, the shell becomes both a program itself and a parent for other programs. So the environment it holds tends to be inherited by the things you run inside it. This is why environment differences can ripple outward into tools, scripts, and even graphical applications launched from a terminal. Beginners sometimes assume the operating system is a single fixed configuration, but in reality, each process has its own view of the environment. The shell is important because it is where you often interact with the system, and it is also where many environment variables are defined and exported. When an exam question suggests that a command works for one user but not another, or works in one session but not another, environment context is often the hidden reason. PATH is one of the most important environment variables because it determines how the shell finds programs when you type a command name without a full path. If you type a program name, the shell searches directories listed in PATH in order until it finds a matching executable file. This means PATH is not just a convenience feature. It is a decision process that can change which program runs even when you type the same name. For beginners, the key idea is that a command name is not always a unique identifier, because different directories can contain executables with the same name. The order of directories in PATH therefore matters, and small changes can produce big effects. A common failure mode is thinking a program is missing when the real issue is that its directory is not in PATH, so the shell cannot locate it. Another failure mode is running the wrong version of a tool because the PATH order points to an unexpected location first. It is also helpful to understand that PATH is not a magical system-wide list that never changes, because it can be influenced by startup files, user preferences, and sometimes by software installers. A user might add a directory to PATH to make personal tools easy to run, while another user might not. The system might set a default PATH for all users, but then a specific shell configuration might modify it for interactive sessions. This is why scripts that run under a different context, like scheduled tasks, might not have the same PATH as an interactive terminal. The exam often tests this indirectly by describing that a command works when typed manually but fails when run in an automated context, which is a classic sign of a different environment. The conceptual skill is to remember that PATH is part of the environment and is therefore dependent on how a session started. Once you think that way, you stop assuming that the command name alone guarantees the same outcome everywhere. HOME is another essential because it anchors the idea of a user's personal space and the default location for many behaviors. HOME typically points to the directory that represents the user's home, where personal configuration, documents, and user-specific data live. Many programs use HOME to decide where to store per-user settings, caches, and history, which is why it affects more than just navigation. For example, the shell itself often stores history and configuration under the home directory, and applications launched by the user may look there for dot files that tweak their behavior. The key beginner insight is that HOME is not just a place you can go. It is a reference point used by software for default paths and storage. If HOME is incorrect or missing, programs can behave strangely, such as writing configuration into unexpected locations or failing to save state. On the exam, when you see a scenario where a user's settings are not being applied or where a tool cannot find its configuration, thinking about HOME and user context is a good move. It is also worth connecting HOME to the concept of identity and permission because home directories are tightly tied to user accounts. The operating system expects that a user has a place where they have appropriate permissions, and many workflows assume that reading and writing in HOME is safe. When that assumption is broken, such as when permissions are wrong or when the home directory is not available, you can see failures that feel unrelated to networking or storage at first. A shell might start but not be able to write history, an application might not be able to save preferences, or a login process might fail because it cannot set up the user environment. Beginners can misinterpret those failures as the application being broken, when the real issue is that the user context is incomplete. This is why Linux Plus cares about home directory concepts, because they connect file permissions, account configuration, and everyday usability. HOME is a small variable with big consequences, and knowing its role helps you reason about many seemingly different symptoms. PS1 is the prompt string variable, and while it might look cosmetic, it is a powerful tool for understanding your context and avoiding mistakes. The prompt is what you see at the start of each command line, and it can include information like your username, the host name, and the current working directory. Beginners sometimes ignore the prompt, but it is often the most immediate clue about where you are and who you are acting as, which matters for permissions and for safety. A prompt that clearly shows you are in a sensitive directory or acting as a privileged user can prevent accidental destructive actions. PS1 can also include visual cues that help you recognize whether you are in a local shell, a remote shell, or a specific environment, which is useful when you work across multiple systems. For exam thinking, the prompt is often used in question text to hint at the current directory or the identity context, so understanding what PS1 represents helps you interpret those hints. Even if you never customize it, knowing that the prompt is a configurable part of the environment matters. When beginners customize PS1, they sometimes run into confusion because prompt configuration is usually applied through startup files, and different shell sessions read different startup files. This brings us to the concept of startup files, which is the most important part of the episode because it explains why environments differ across sessions. A startup file is a script or configuration file that the shell reads when it starts, and it can set variables, define aliases, and adjust behaviors like the prompt. The tricky part is that shells can start in different modes, such as interactive or non-interactive, and login or non-login, and those modes influence which startup files are read. You do not need to memorize every file name for the exam, but you do need the concept that there is an ordered process that builds the environment when a shell starts. When you see inconsistent behavior, you should suspect that different startup files were applied, resulting in different PATH values, different prompt settings, or different environment variables. A helpful mental model is to treat startup files as layers of configuration, some global and some user-specific. Global configuration affects all users and is often used to establish system defaults. User-specific configuration lives in the home directory and allows each user to customize their shell behavior. This layering is why two users on the same system can have different prompts, different PATH entries, and different default behaviors even though they are using the same shell program. It also explains why a shell session that starts as a login session can look different from one that starts as a non-login session, because different layers of configuration may have been applied. The exam often tests this by describing that a setting works in one kind of session but not another, and the correct reasoning is that the configuration was placed in a file that is not read in that mode. If you understand the layering concept, you can diagnose where the configuration should live conceptually without needing to memorize the exact file names in every distribution. Another key idea is the difference between environment variables and shell-only variables, because it influences what child processes inherit. An environment variable is generally something the shell exports so that programs it launches can see it. A shell-only variable might exist only inside the shell and not be visible to programs that the shell starts. This matters because PATH and HOME are intended to be environment variables that affect how programs run, while some prompt-related variables might matter only to the shell. If a beginner sets a variable and expects it to affect a program, but it does not, the missing piece might be that the variable was not exported or was set in a context that does not apply to the program's execution mode. For exam questions, this shows up when a program behaves differently under automation versus interactive use, because automation might run under a shell that does not load the same startup files or does not export the same environment. The mental habit is to ask, is this value part of the environment passed to programs, and is it being set in the right startup context? That habit turns a vague mystery into a concrete checklist. Environment context also interacts with security in a way beginners should respect, especially around PATH. If PATH includes directories that are writable by untrusted users, or if the order places unsafe locations early, it can create situations where the wrong executable runs. This is not just theoretical. It is a common class of misconfiguration that can lead to unexpected behavior or even compromise. The exam may not ask you to design a hardened PATH, but it may test awareness that PATH order matters and that blindly trusting a command name can be risky. A safe mental habit is to understand that a full path is the most explicit way to refer to a program, while PATH is a convenience layer that can vary by environment. In troubleshooting scenarios, knowing that the command you think you are running might not be the one actually executing is a powerful insight. This also connects back to startup files, because they are often where PATH is modified, and a modification intended for convenience can have side effects. All of these pieces come together when you explain why two sessions can differ, which is one of the most common beginner experiences. If one session is started as a login shell and another is not, they may read different startup files and therefore build different environments. If one session is interactive and another is non-interactive, certain customizations might not apply, which affects things like aliases, prompt, and even PATH changes. If one session is started under a different user account, HOME changes, which changes where per-user configuration is read from and where programs store settings. If one session is started by an automated system rather than by a human, it may have a minimal environment with only basic variables defined. These are all predictable outcomes of the shell startup model, and they are exactly the kinds of subtle distinctions the exam wants you to notice in scenario questions. You do not need to type anything to learn this. You just need to understand that a shell's environment is constructed, not assumed. By the end of this episode, you should be able to describe PATH as the ordered search path the shell uses to locate executables, and you should be able to explain how changes to PATH can make commands appear missing or make the wrong version run. You should be able to describe HOME as the anchor directory for a user's configuration and default storage, and you should recognize how a broken home context can create strange application behavior. You should be able to describe PS1 as the variable that shapes the prompt and provides context cues that help prevent mistakes. Most importantly, you should understand startup files as the layered scripts that build the environment differently depending on how the shell is started. When you see inconsistent behavior across sessions, your instinct should be to ask what kind of shell started and which configuration layers were applied. That single shift in thinking turns a common Linux frustration into a predictable, explainable system behavior.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.